there's some concepts inside 2.3 that are pretty fundamental, pretty, I think, simple for the most part, that allows us then to maybe address using our calculator and dealing with some functions on our calculator that you might see useful in this particular area, but hopefully maybe it's something that's going to be useful for the duration of the course and other courses that you use TI 83 or 84, or even an 89 or something that TI Inspire. They're all kind of consistent. And logically, it's the information that we learn and gain from this can be used inside any other graphing tool. To go to the internet and type in, graphing applet or something like that. There's endless numbers of calculators that you can find. But if we understand the logic and the math that's involved with what we do here today, you can apply what we learned with TI-83 to any other kind of graphing tool that you come across. So you can get online, like GeoGebra is 10 times the calculator that the TI-8384 is, and it has similar procedures, similar ideas and concepts wrapped up into it, and it's free. So your TI-83 is what, $110? This guy TI-89 is like $200. GeoGebra is free and it does so much more. Same thing with, you guys ever heard of Desmos? Okay, I think Mrs. Coles uses Desmos a little bit. I don't know if she used it with you guys last year or not. But it's a free graphing calculator. It takes a little bit to learn its notation, stuff like that, but and its user interface, but it's a pretty good calculator. You can get it on your iPhone, it's free. If you're a person that likes to graph things or needs to graph things, but only when you use the TI-83, that's an option. You can also, it's got a web interface to use, www.desmos.com, something like that, and you can access that calculator. But basically what we're doing here is comparing values from a function and seeing what they tell us, graphically. Okay. So the first thing we'll talk about values of function, of a function that are related to the domain and range. Kind of skipping through some stuff here. If we look at this function here, it's a function of temperature based off of some time value. Okay. Now I'm going to write it this way. I just want to make sure that we all understand notation stuff. Okay, because it's very important for information that you gain from the way that they write a function or a set of ordered pairs. If they write an ordered pair like this, x comma y, okay? If I see that I know nothing about the function, or sorry, not even the function, the equation that x and y come from, okay? And there's nothing about it because they're using x's and y's, okay? It's the most kind of elementary, least explicit way of writing an ordered pair, okay? But if I write something like this, T, comma, capital T of lowercase t, okay, because I see that right there, okay, that tells me that capital T is a what? If I wrote something like this instead of y, okay, it tells me that this thing here is a what? Function, okay? This is a function. Does that make sense? Okay, it doesn't matter what letters they use. They can use, we're going to use things that are kind of indicative of the experiment or what the quantities represent inside the problem. So capital T represents temperature. Lowercase t represents time, right? But temperature is a function of time. So that notation, okay, we call that function notation, tells me a lot more about my graph and my problem than what that did, okay? This tells me I'm going to pass the vertical line test. This tells me no matter what t value I choose, there's one and only one temperature that's going to go with it, okay? X comma y does not say that, all right? So this is a little bit more informative to us in regards to maybe this particular problem. What they're going to ask you in your homework, okay, very elementary type things. they're going to say, hey, can you find t of 2? And t of 2, so 2 is representing the time, right? Okay, so that's the, they got an x down here. I'm going to change that to a t. But that's the horizontal axis. You may remember back from science, and we've talked about this before because we used our calculator a little bit. What is the horizontal? What do you, probably 99.9% of the time, allow your horizontal to be what variable? Will that to be t or x, but what do we call, what's the vocabulary word for what we call that type of variable? Independent, okay? This is your independent variable. This becomes your dependent, right? So they're going to ask you, look at a particular independent value. So 1, 2, 3, those do not rely on anything else, right? Those are things that we cannot impact time, correct? Okay, so that's why we call that's independent, okay? But this one, this y value, or t of capital T of lowercase t, okay, that function value, the output value, is dependent on what input value we use, right? Okay, this height, okay, if I'm at 1, the height is, what, 25? Okay, if I'm at 2, the height is 35. Okay, so t of 2 is 35. So there's my independent value. 2 could have been anything. But once I choose 2, this number here, this 35, depended on 2. Is that okay with everybody? Okay. So that's what they're going to ask you. And they might phrase it using words like dependent and independent, that kind of stuff. I think that's useful when you're in science to understand that logic. Okay. Because in a science class, maybe a physics class or a chemistry class, you're going to use quite a bit of algebra. Maybe you're doing a lab experiment where you're trying to fit, like maybe you've got maybe you did this. Maybe this is, instead of this is temperature of a weather station, maybe it's temperature of some type of solution at some point in time. And you're measuring the temperature every hour or something like that. You will then use those data points to help you build a curve. Maybe it's a curve, we call them curves of regression. Could be a line of regression. You guys ever heard of lines of regression? Best fit line, you ever heard that? Okay, those are lines of regression. You have quadratics of regression, you have cubics of regression, that kind of stuff. Basically, it's just looking at a series of points and seeing if it's like the best fit curve to those. And so far, probably in science, you've dealt with lines being that curve. But you can do that with a lot of different other functions. So you might do that in a science class, and it'd be nice to know what your independent, dependent variables are, and they use that terminology. They might ask you what t of 3 is. Okay, so t of 3 is going to be, what is that, 30? Okay. The next thing they're going to ask you is what's the net change? What is the net change between 2 o'clock and 3 o'clock? Okay, so the net change between 2 o'clock and 3 o'clock. All we have to do when they ask the net change, okay, and net just means total, right? Okay, so net change is, in this case, between 2 and 3 is 35 minus 30. We just subtract the output values. 35 minus 30, and that's going to give me 5, right? Okay, so from 2 o'clock, so that 35 to 3 o'clock, it's a net change of 5, and it's decreasing in that instance, right? Okay. Whenever you see the phrase net change, the way just because I have a kind of a sports background, the way I understand net change is through like yardage for like football. Okay, we could have maybe 200 yards rushing and 100 yards passing, so it'd be 300 total yards, right? Okay, but we might got sacked 3 times and lost 20 yards. So my net yardage is 300 plus the negative 20 gives me 280, right? Does that make sense? And that's how I remember what net means, okay? And if you think about like net income or something like that, it's basically everything you earn after like taxes and insurance and everything's taken out, okay? Gross income or something like that is before anything is taken out. Does that make sense? Okay. So that terminology is is useful, and a lot of times in a math class they expect that that is something that you guys know, and I know that's not something everybody knows. Okay, so net change is that idea. You might also see, and we'll talk about this in other sections, but they might say average rate of change. Okay, well, average rate of change is something you've been doing since the 9th grade. What was one of the most important things in Algebra 1 that you guys talked about for lines? Slope. Okay, slope is the exact same thing as average rate of change. Okay. So if you hear that phrase, it's a way for them to say slope, but it may be a better phrase than what slope is. Average rate of change. Well, rate is kind of a speed, right? What we talk about, okay? Change, okay? So it's how fast the speed or the amount is changing. And if I look, so if I look at these two things, the average rate of change between those, because when we took the y values, basically the output values, subtract, we got a 5. Now the difference in time was 1, right? Okay. So 5 divided by 1 would just be 5. So the average rate of change here is the exact same thing as the net change. But if I were to choose something like, instead of t of 3, let's go t of 6. Okay, so t of 2 was, again, 35, but t of 6 is, I don't know, let's make it easy. Let's go 8. Let's go, 18 is fine. What's 35 minus 18? 17. Okay, and now over that period of time would be 4, right? So 17/4 would be our average rate of change. Okay, so whatever that is as a decimal, we'll say 17 divided by 4 is 4.25. Okay, so what we're seeing is that we're getting a 4.25 change in temperature, degrees, and it's a decrease per hour from 1 hour to 6 hours. Does that make sense? Even though there was a situation in between 1 hour and 6 hours that we increased, right? Okay, but the average rate of change from 2 to 6, that average rate is still declining, correct? Okay, so that's something to think about as you see terminology inside a math course. We've got two words, slope and average rate of change, that mean the same thing, but average rate of change, I think, is a little bit more explicit in what they're trying to get at. Okay, average rate of change is a very, 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 very important concept for calculus. You'll deal with derivatives in calculus, which is just slope of any curve at any point, and we use average rate of change to do that. Okay, and you spend, in a high school course, you probably spend up and past Christmas dealing with average rate of change. Maybe not directly, but indirectly you use it all the time in that class. We've talked about values of a function, looking at domain and range. Just want to make sure that we clear things up. I'm still seeing some people, and it's just human nature, I think, when we read, if I read this phrase here, the graph of a function helps us to picture the domain and range of the function on the axis and y-axis shown in the box below. I read that phrase, it's how I was taught to read in first grade, left to right, and then down the page, right? Okay. When we read a graph, still left to right, okay, but we read it left to right and bottom up at kind of the same time, okay? Because what we want to do when we talk about our range is our range values, when we put them in interval notation, they need to be the smallest value first, okay, and then your largest value second. And the only way you can do that is if you look at the smaller portion, the negative y-axis first, and then read your way up. And that will put your interval notation in the correct order. A lot of times I get, people usually get the domain right, but let's say that value there is 10, and that value is 2. That's not a 2. I don't know. It's Monday. That value is 2. I get a lot of people write 10, 2 as their range. Okay? And they say, well, I got the right values. Yeah, you do, in the wrong order. And when you put them in the wrong order, you're telling me that 10 comes on the number line before 2 does. Not obvious, or not correct, right? Okay. So we want 10, 2. Is that doable? Okay. We see it all the time. It's a huge mistake. Just want to make sure that we do not do that on the test that will most likely be next week at some point. Ooh. All right, let's go over calculators real quick. Okay, whether you want to use calculator on your computer or the handheld, I think the handheld's probably, you're going to be a little bit more efficient with it. On your test on next week, and I'm not sure what day yet, but it'll be towards the end of the week. It's going to be useful for you to have the handheld. You're so much more efficient with the handheld in regards to speed and pushing on the calculator. I hate this calculator on the computer. But it does serve its purpose for the class to see. I want to graph, we see the function here. It says 4, the square root of 4 minus x squared. Square root of 4 minus x squared. That's the problem. Give me a second real quick. I want to... All right, so some of you, when you... And this is... Like Chris, I think yours is going to do this because it looks like you have one of the newer ones. And it's all... I was looking for... Like, this is the 2.43 version of this ROM. I'm looking for the 2.55 version. And I'll find it tomorrow or later today and show you tomorrow. But if I hit the mode key... My mode key is going to allow me to scroll down basically 10 lines, and it's got information on all those 10 lines. But some of you, with the newer calculators, you can go beyond those 10 lines. So if I scroll all the way down, okay, set clock, and then there should be like a next option, right? Is that correct? I have language. Okay. Does anybody have where it says like math print or classic? Okay, so some of yours. Like this one, okay, which it is cute. Zach's got the same color. All right, so at the top it says math print or classic. If your math print, I think it's useful, but it also kind of gets you in trouble. I think maybe in other programs if you want to use other programs because math print doesn't always exist in other programs. But math print, what it does. It's just like this. Say I want to type a square root in. Okay? We hit our second square root key, and it will give me, turn this off. It will put that in there, and it will put a box in there, and I can start typing whatever I want to, and it will extend that square root bar and tell me exactly what is underneath that square root. Does that kind of make sense? Okay? So when I have, I think it was like x squared minus 4, or no, it's 4 minus x squared. So if I want to type that in, now I get to the x squared part. I want to hit my caret key, right, to get exponents. Well, when I do that on a math print, it's going to put that little box up there where the exponent goes, and I put a 2 in there. And now I know that I have typed in exactly what I want to type in because that's how it was written, right? Okay, math print, kind of like how you would write it by hand. There are some, like on the TI 83s or 84s, okay, you can see that like those were the color edition, has that, and some of the monochrome ones, the black and white or whatever color those are, also has that function if you go scroll far enough in those windows. But if I hit second square root here, okay, now it just opens a parenthesis, and now I've got 4 minus x squared. Okay? Still puts the x squared up there, but sometimes, even though and this is an updated version, but sometimes, like my TI-89, which is a much more advanced calculator than this, doesn't have that power of 2. You've got to write it that way. Okay? I've got to understand that syntax of how to write things. Now, what gets you in trouble is that I could graph this, and it'd be right just the way it is, but I need to understand that I need to start putting parentheses to enclose everything that should be underneath that radical. Does that make sense? Okay? Because there will be a situation where we have maybe we have f of x is equal to the square root of 4 minus x squared, but then we want plus 3. Okay? Well, if I put that plus 3, if I just forget square or parentheses and I do that, that is going to be incorrect. Okay? Because that plus 3 needs to be on the outside of the parentheses. Or sorry, outside of the square root. Okay? Which would still be on the outside of the parentheses. Where if you're in math print, you can push your directional key over and it will end your square root bar, and you can push plus 3 and you can see what is underneath and what is on the outside, and you're good to go. Okay. Some graphing tools, if you're to get onto, like you guys obviously know I like to use GeoGebra. I can't. There's no square root key. I have to hit SQRT parenthesis, type whatever I want inside there, close the parenthesis, and then hit enter. Okay. So that's some notation stuff that's important. Most people, I think, once they recognize that they have the ability for math print, they prefer that. But as we do things, I will always put it in kind of the default classic mode. It's the most kind of generic, simplistic mode. And the reason I do that, say you forget your calculator at home and you need to borrow one of mine. All mine are classic. Does that make sense? Okay, so you need to be able to use that tool. And when you get into other programs, other applets, other graphing tools, most likely they're going to be programmed this way, where they don't have math print. Okay, I'm going to graph that, and when I graph that, it looks kind of elliptical, doesn't it? Okay, but the hope is that we realize it should not be elliptical. Because let's do this. Let's say that I have right over here, so we can see it on the video. But if I had the function f of x is equal to the square root of 4 minus x squared.
Pardon the interruption. We have a Volkswagen vehicle parked in the van parking lot. You've left your lights on. A brown Volkswagen parked in the van parking lot. Volkswagen with your lights left on. That is usually a sign out in the office. Keep your lights on. Thank you.
All right, so if I interchange the f of x with y, because a lot of times when we do algebra, I'm trying to realize what this function should look like. It's easier to do that algebra with y, do the algebra, then plug back in f of x later. But if I square both sides, I would get y squared is equal to 4 minus x squared, right? Add x squared to both sides, I get x squared plus y squared is equal to 4. The first week of school, we dealt with that function a lot. Right? Not a function, that graph a lot. X squared plus y squared equals 4. What is that? That's a circle, right? Okay. This thing does not look circular, correct? And to get the entire circle, we would actually have to have a plus or minus here on that portion, on the f of x portion. Okay. So you need two functions there. But that is not circular. And the reason is, if I count, you can see kind of maybe the pixels on here, like that little, I can't draw on it. If we zoom in far enough, you can start to see, can you guys see the kind of the grayish pixels in here? Okay, from the far left side of my x-axis all the way to the far right-hand side of my x-axis. No, can't talk today. There are more pixels horizontally than there are vertical. That's a rectangle, right? And the view screen is a rectangle. So that's going to distort things. It's not a one-to-one relationship in regards to maybe that distance right there on the y-axis and that distance there on the x-axis. Okay, the y-axis is scrunched a little bit more than what the x-axis is, right? Okay, so in order to maybe fix that, we can do a couple different things. We go to the zoom key. All right, and standard is what it's in right now. 6 is what your calculator, for the most part, is probably in. If you bought it from the store and that's the first time you opened it, it's in 6. Okay, it's zoom standard is the default way of graphing. Okay, but I want to go to zoom square because that's going to take my viewing window. Okay, and it's actually going to put in more x values. Okay. Because now it's going to scrunch the x values the same way the y values were, And now you can even kind of verify that when you go to the window, and you see that it was from negative 10 to 10, but now it's changing from negative 15 to positive 15. Okay? So when my window is from negative 15 to positive 15 and negative 10 to positive 10 on the y-axis, it's pretty much squared. Does that make sense? Okay. So now it kind of looks circular, doesn't it? Semicircular. It's still kind of crappy looking, I think, because we're really zoomed out real far. So let's go to zoom again. And maybe a tool that you have not used before on this calculator in the zoom functions is number one, zoom box. Okay? And I think it's one of the most overlooked functions that your calculator has that becomes very useful. I go to zoom box and it puts this cursor, I'm allowed to move that cursor around, but what happens when I hit enter, it changes to that, right? And really what this is a cropping tool for us to say, I just want to look at that. So I zoom in, or I put my cropping window around the part of the graph I want to look at, and that's going to auto-fit it real nice and in a big viewing screen for us. Is that okay? What I want you guys to understand is when we graph something like this, there are limitations to your calculator. So the graphing, the look in the graph, doesn't always provide you with the exact same information that the algebra would. So I don't want you to use your calculator as a crutch to learn the algebra. I want you to back up and verify your algebra. Because what we see here, with this function, we should have been able, with this function, we get a domain of negative 2 to positive 2, and we get a range from 0 to 2. So we should get points. Okay, I should be able to plug in negative 2 and get a point back. So there should be a point graphed right there. Okay, and then I should be able to pick a number just to the right of that and pick a y value back. So anything here that's red should actually be graphed. Does that make sense? And just because of the limitations of my calculator, because of the pixels and stuff like that, it doesn't necessarily show that. Those of you that have the colored ones, the can I see yours again? Ones like Callie's here, yours even does it, right? Hers kind of, it's symmetric, but it still kept short of the x-axis, okay? Which is not indicative of what's really going on with that function. So that's, I just want you to be cautious of that and leery of that when you're doing something like this. The algebra that we do is irreplaceable. Okay? You cannot use this technology to get all the information you need. Does that make sense? Now, there are better graphing tools like GeoGebra, better graphing tool, Desmos, better graphing tool, that will show you all those points that you need. Okay? I haven't worked with Desmos very much. It might even, some of them might even give you open dot, closed dot, depending on whether those x values should be part of the domain and range values as part of, or y values as part of your range. Another place you can look for range and x values or range and domain values is to go to your second table. Okay, but this is kind of maybe a bad thing to do initially because I do see, you see these errors, right? Whenever you're on your calculator, you see an error over here. Basically tells you that these x values were not part of your domain. Does that make sense? Okay, because if my x value is part of my domain, I should be able to plug it in, and get a y value back, right? Here it's saying you plug 5 in, but you don't get anything back. Because if I plug 5 in, I get 4 minus 25, which is negative 21, right? So I'm getting the square root of negative 21. Well, that's not a real number, so that's why it's spitting back an error to me. Okay? So we see here that the errors continue all the way past 5. Okay? So it kind of provides insight to me that right here is maybe the cutoff between 2 and 3 might be the cutoff for my domain value. Does that make sense? But just because I'm increasing my x values by integers by a whole value of 1, I'm not really seeing, is 2 really the last value that works, or is maybe 2.1 the last value? Does that make sense? So what I would do is maybe go to my table, so second window, and I'm going to go down to delta table, which means change in table. Okay, so it's a change in x values. So maybe I change it to 0.1. And now I go back to my table. And now I'm going to go find that 2 again. And now we see at 2, then it goes to 2.1, there's an error there, right? So now I know that my domain is at least between, it should end at least between 2 and 2.1, right? But hopefully you can start to see maybe the little game we can play here. And now I can go maybe 0.01. I'll get this thing to start at 2. Go to my table. And now we see that between 2 and 2.01 there's an error. That kind of makes sense? I can't really narrow down whether 2 was my last x value in my domain, or if there is a number just to the right of 2 that should be included. Does that make sense, everybody? Maybe it's insightful after or useful after you've dealt with the domain algebraically to go to the table and say, yeah, does it make sense from the table? And we have done that. We do know that 2 should be my last domain value there. So maybe my table is useful here. But initially, I would not use the table to determine what my domain and range value is. Does that make sense? But once I do find my domain value, maybe I do know 2 is my domain value, my endpoint of my domain. And that gave me a y value of 0. And then I search through and I find, let's actually go, just to make it easier to search a little bit, the window. Let's just make this go back to 1. I don't know why it changed the table start and all that kind of stuff. That's kind of maybe, but I want to start at 2. So I see at 2, I get a y value of 0. And I keep going through, and I get to -2, I get another y value of 0. So now could I look at these y values right here and determine, if I know -2 and 2 is my domain, is it kind of easy maybe to see what my range values would be? What's the smallest range value you get up there? 0, what's the largest range value? 2. Okay. Now it still might be a good idea instead. I increase my interest because it just makes it a little bit easier to discuss. But it might be a better idea to maybe increase those by maybe 1/4 or 0.1, something like that, so you get a better view of what your y values really are. Okay? But that's an option. Make sure that you're understanding how we write this square root. That's the number one error that people come across. They come to me and say, I'm doing everything right, and it happens a lot with division and square roots. They think they're doing everything right. They've missed a parenthesis somewhere. They've added a parenthesis too much, and it's graphing something different than what they were providing. What's nice with the calculus, let's say I wanted to graph this thing. Let's say I wanted to change the domain. The domain was from -2 to +2, right? Let's say I want to change the domain from just 0 to 2. Okay? What I can do, and I think I need to put the whole thing in parentheses. So let's go second insert. I'll put a parenthesis there and a parenthesis there. So I'm just clustering my function in its own set of parentheses. Okay? It's called Boolean notation. Okay? In Boolean notation, kind of, if you know anything about like computer program or anything like that, it's basically true or false question. Okay? So I'm telling my calculator to look at this function here. Okay? And I want to basically run through a bunch of x values, and if the x values are true, I want it to graph the y values that go with it. Okay? So I'm going to say I want to graph x values from 0. So I'm going to hit 0. Okay. Now I'm going to put an inequality in because I want to change my x value. So I'm going to hit 0. And now to get inequalities, anybody know how to do that? I go to second, and then my math key. I'm just going to go to test. I'm just going to go down to less than or equal to. So 0 is less than or equal to. I'm going to hit x. And now I'm going to go second math again. Hit 6. And then let's go 2. So what I just typed in there is 0 is less than or equal to x is less than or equal to. Close that off. If we've done this right, and hopefully we have, I hit graph. And it didn't do it right. Did anybody's graph x is 0 to 2 should just graph the first quadrant? Anybody do that? Well, that's not what I planned. I haven't used Boolean notation in a long time. I'm pretty sure that's how you do it. I'll double check, see what I'm doing wrong. Obviously, I guess it's not how you do it. I'll double check tomorrow, today, a little bit, tell you tomorrow how to do that. But it's nice for the piecewise stuff. Okay, that's why I was trying to show this to you. You can use this in piecewise functions to graph your separate functions. If you have 3 functions, put 1 in y1, 1 in y2, 1 in y3, put their domain restrictions, and then it will graph your piecewise functions. Okay, so that is an option, but so you have to do that in tomorrow. We can compare functions. When we compare functions, okay, we are very comfortable, hopefully, with knowing where f of x, if these are my 2 functions here, let's just zoom in on one of these real quick. If these are my 2 functions, f and g, we have f of x equals g of x. What is graphically, describe what it means when I say f of x equals g of x. What are we looking for? Where do they intersect? Okay. So in this case, we'd be looking at what x values for that. What would be the answer here for where these 2 things intersect? A and B, right? Okay. When we're asked for solutions, we're always talking about x values or domain values that satisfy this condition. So we're looking for what x values do you get back a situation where the y values are equal. Okay? So here, an x value of a, we get back an f of x is equal to a g of x, right? An output for f is equal to the output for g. And the same thing over here at b, we would get f of b and g of b, whatever those y values are, they would be identical, correct? Well, if you know where the functions are equal, you automatically know where they're unequal. Yeah. Okay. Unequal would be everywhere else, right? But usually we want to know how are they unequal. So if I just, let's color one of these green. Okay. And I say I want to know between A and B. Between A and B, which function has y values that are bigger? G would have y values that are bigger, right? Okay. So if I write, can we write f? Can we write this 2 different ways? F of x is less than g of x on the domain from A to B. Does that kind of make sense? Put a semicolon there. F of x is less than g of x. F of x is below g of x from A to B. All right? On a test, when I ask questions like that, and I need the notation, I need these parentheses, so I put a bracket on one of those, I've included an equality, right? So if this is like a 2 and this is a 5, okay, and you put like maybe 2, 5 like that, you got the right number. So I'll give you points for that. But I'm also looking at notation stuff. And you are 100% wrong when you put that bracket in there, because you've included, even though there's an infinite number of values in here, you've got one value that violates this condition here. Does that make sense? 2 is equality, so we can't include that when we're talking about unequal. Now, if I know where they're equal and I know where f of x is less than g of x, can I say I know where g of x is less than f of x? Yeah, it's everywhere else now, right? You found equality, you found where f of x is less than, so now where g of x is less than, well, that's over here, right? So from maybe negative infinity up to A, and then union that with B up to infinity is where we are less than. Okay? And now you can flip those around. You can say f of x is greater than g of x, or g of x is greater than f of x, but the domain values would still be maintained. Okay? Just real quick before we leave, I know it's some information here about increasing and decreasing function. Increasing means going up, right? Okay. So if they ask you what is the range, or so the domain or the x values that your function is increasing, it's where successive x values, or sorry, y, the successive x values provide y values that are bigger. So can you see between A and B here, you are increasing because your y values are getting bigger and bigger? What's happening between B and C? Decreasing. What's happening between C and D? Increasing. What kind of point would you call B? It's a maximum. Okay, it's a largest y value. I gave last class a worksheet. Since you guys are leaving, I won't give it to you today. I'll give you guys an extra day on top of that, but I'll give it to you tomorrow. D is what we call a global maximum. They're both, B is a maximum and D is a maximum, but because this one is a larger y value than that one, we call that a global or absolute maximum. We'll talk more about that stuff a little bit tomorrow.